Okay. Okay. We'll start the lab session. Today with us, Alok is there. He is our MTech research student, and later on he has also founded his company in FTVI, and he is very good at microcontroller based system design, embedded system, and IoT. So he will help us to learn MQTT facts and features and its related operations issues with ESP8266 node Raspberry Pi. Node MC, Raspberry Pi also to us. Okay, thank you. Start.
Hello everyone, good afternoon. So the scope of today's hands-on session will be counting the numbers as 2. So the first one, we are going to focus on wireless switches, which you will be very much aware of those Wi-Fi based switches, where you can control the switches from anywhere configured with the IoT ecosystem. And those are the most vulnerable things if you see in the where the hardware attack can be done through internet. The main focus would be to do this Wi-Fi switching through MQTT, and later on in the second hands-on session we'll be doing this energy monitoring system. That is also a very crucial thing. So that is the sensor we are given. The module is for monitoring the energy, which can give you the values of voltage, current, power factor, frequency, energy, all the data. And the communication protocol we are going to use for today is MQTT. MQTT is, some of you must be aware of the protocol. What is MQTT? Anyone? What is MQTT? Message queuing protocol. So it's basically this is a queue-based protocol. What is a queue? So if you see in the conventional HTTP-based systems, there you see like client-server architecture. In that, the client waits for a response to come from the server, and then only there's a response like 200 OK response comes. Then only you can decide. I mean, you can say or justify like there's a connection made between the client and server. But it was very heavy because of the metadata associated with that. Lots of data associated with that, so that became very consuming higher energy. And in case of battery powered systems, which are widely used in IoT applications, so the current consumption was more. So IBM started devising this protocol. They designed this protocol for their personal use. Later on, it became open source. So MQTT, message queuing telemetry transport. What is a message queue? That we need to understand first. So let me tell you what is message queue. So the message queue is like this. A message waits for finite amount of time until it gets delivered to the client. So it stays in a queue. It stops and it stays in a queue. So the last value are retained. So in that communication mode, you think of this wireless switches. Think of the power goes and the internet failure comes, and you don't have to again press it to turn it on. It stores the value. It retains the value. When the internet comes or power comes, it automatically should turn on the light or any load you are using. And Wi-Fi based switches are very much predominantly used in the world everywhere. Mostly, if you see all the consumer appliances, they are being connected through IoT, and they use MQTT in general. So we'll have some basic idea about the protocol. So this is simple to implement. Quality of service. So it provides you quality of service delivery. Like there are 3 modes of delivery: QoS 1, 0, and 2. 0 being the lowest priority. You should always go for 2. and depending upon the requirement of your application. Lightweight and bandwidth efficient, where the bandwidth is very low, you are not, you have very less bandwidth. There also in those applications you can go for this MQTT protocol. And continuous session awareness. Session awareness is like, so it's a persistent session. So the connection is always there. So I'll tell you. This is how the network looks like actually. In client service based architectures, you see, there's a client and there's a server, and there can be one and two. So like this they communicate, and you wait for the response to come. When you send something, the response comes, then only you can say, okay, the communication is established, and you can carry on. And again, you can go with socket programming so that persistent connection is made. But in case of MQTT, in case of HTTP, if you see the client server based architecture, what you need in general a port and an IP. You need the client to communicate to the server. And obviously, for point-to-point communication or machine-to-machine communication, you'll obviously need to go through a common medium. It can be server in case of HTTP. It can be a broker in case of MQTT. Obviously, there is a medium where you need to communicate between two devices. But yes, the metadata associated with this architecture is very low and very fast in case of MQTT. So in case of MQTT, what happens? The client, this is the client, and there are, this is the client and these are also clients, C2 and C3, and this is C1. So let's say it's a client which is only publishing data. This is not getting any data, it is only publishing. So it's generating data. Think of a pollution monitoring device. So it can give you PM data, ozone, all the parameters like which are associated with pollution. So it is just publishing. So in this case, in case of MQTT architecture, C1 doesn't know the existence of C2 and C3 at all. It need not know the existence of C2 and C3. It can also work if there is no C2 and C3. Saying like what I mean to say, so this is publishing. This is the server which has become a broker in case of MQTT. And this broker's job is to provide the data to the subscribers. This being a publisher, its job is to provide the data to the subscribers which are subscribed to this topic. So in this architecture, there are some, the protocol has clearly defined. You have to go through some topics. Let's say this is a device one. I can say device one, and I have a parameter called PM 2.5. This is my topic, and these are the device which they want to get the data from this. But so they have to also subscribe to this topic so as to get the data. If there is no subscriber, this value never goes to any subscriber. It just stays here. In the sense of the MQTT broker, it just stays here. It's simply, you can take the example of YouTube. You are getting the notification of the channel which you are subscribed to. You can search and find, but that doesn't make the MQTT being the architecture of YouTube notification. But yes, the channels which you are being subscribed to, those notifications only you get, and other notifications you never get. You can have this home page and all, and you can search. So here you have this topics. Let's say there is one more publisher, which is like let's say C4, and this is you have installed like hundreds of devices, so you can have like device 2 and EM2.5. EM2.5 being the parameter, so I'm just taking the name and to signify like this is the device 1 and device 2. So I've taken device 2. If this is a home application, home appliance, you can have lights, fans, AC and all. So you can have home/AC /1 because there might be 2-3 ACs. Home/light/1, home/light/2. So you can have multiple. I mean, it doesn't limit you to stop. Like, okay, you can go till 3 layers. You can go deep inside this. The job of the broker is to handle that. You don't care, the broker will care for you. So accordingly, while you're planning the device, no, you have to set up these topics. So while designing and while programming these topic things, that can be clear. For a single device, which is publishing, you don't have to care for this 1 and 2 notifications. So MQTT can run in a microcontroller like this ESP32 you are being USB826 you are being given in a PI in a system, in a Linux server, in a cloud server, anywhere you can install the MQTT. So MQTT is just a protocol, but for that you have to install Mosquito. It's the name of the broker. Mosquito is the broker name. You just have to install and allow access, for the clients, and it runs in the port 1883, the Mosquito broker. MQTT broker in general for this, and obviously HTTP, like if you see below HTTP, what you have TCP/IP, right? In this layers. Here also MQTT, like you can say, this is also in the application layer. This also, and I mean, it's done through TCP/IP only. So for this, you have to install this Mosquito broker. So it's a software, it's open source. So you all are being given a PI. There we have installed the broker Mosquito and have given access to this broker. So anonymous client, anyone with a valid topic can connect to this broker and can be a part of the network. MQTT, below MQTT, if you see, there is TCP and TCP/IP is there. So these are we'll move on in a minute. So this is how this connect message session started. I mean, while you program, obviously you'll be using some library, and this MQTT library is have support with C, Java, Python, Arduino IDE environment, you can use any type of IDE and can have support for this MQTT protocol. How this connection occurs? This is this client ID, clean session, username, password, last build topic. So these are the things which are being sent to the broker to initiate a connection. Then it sends acknowledgement to this. That's how this session is established. You can also unsubscribe from a topic. I mean, please C1 and C2. There is C3. And there is this broker. And C2 and C3, they don't want to have the data of C1. It can also unsubscribe. When this page subscribed, but this can unsubscribe. So this C1 data, when sending on a particular topic, will never reach to this. That's how YouTube unsubscription option is there. So that's how you can think of. We'll share you this PDF. This is the biggest public broker is handled by HiveMQ. Millions of devices they are getting connected through this HiveMQ broker. And while talking about HiveMQ, we are talking cloud broker. But in today's session, we'll be using the local broker, where the Pi being a broker in the local network. Because we don't have connection outside the port connection. This 1883 is banned for an 80. Other than 80, you cannot connect to other ports. So we'll be using the local broker for today's session. We'll be sharing this PDF later on. Now we can start working on our first hardware, which is a Wi-Fi switch with the ESP8266. For this, obviously you will need Arduino IDE, which is installed for you, but you have to install the support for the ESP8266, which is not by default. For that, you have to install a JSON file. I will be sharing with you. You can open Arduino IDE. Broker is maintaining the queue.
If we know people is getting the topic and the ISO and which is going to receive it, then where is the concept of queuing?
Ma'am,
Publisher and subscriber type of model.
Yes, I'll tell you. Let's say this is subscriber. This is a publisher. This is a broker, and this is C2, which is the subscriber. Now, by talking about message queuing, let's say there was no device connected initially. This is only publishing, and there was no one to receive, no one to subscribe. So, if you are setting the retain as true, it will put that topic, the data, data of that particular topic in a queue until it is sent to someone. Let's say it has sent the data today, published today. There was no subscriber today. There was also S2, which was getting data. It was not connected. Now let's say this was not there. I mean today not there. It came tomorrow. Let's say it is coming tomorrow. What about the data which is being published on that topic? Will it go to this if it is subscribes to its topic? Say home plus light plus one. So obviously this will reach to the subscriber tomorrow because it stays in a queue. The job of the broker is to filter, send to the respective subscribers, and also to put those data of different topics in a queue so that they get they are whenever someone gets connected, it reaches to the its soulful subscriber. That's how it stays in a queue.
That will be not assigned to the corresponding subscriber that will be very active.
Yes. It stays in the queue. So the sessions are stored actually always. Now we'll see today how this queuing will come. Go to File and Preferences. I'm just writing here. Can you see this? Can you see this? Or you can write HTTP. Go to File, Preferences, and then Additional Board Manager. File, Preferences, Additional Board Manager. Here you can write. I'll call it loudly so that I think it's not visible from here because of the brightness. I don't have a thing. I can call them. It's very short. HTTP colon. You can write HTTP colon 2 slashes. Okay. Radio. HTTP colon / Arduino.esp8266.com /table /package _ esp8266.com _ index.json. HTTP colon
Do one file कराओ कड़ी से कॉपी करके ये दिखा हुई फॉन्ट
Yeah. Now can you see? Now it's visible. I think it's visible now. After you are done with entering this JSON URL, in the preferences, press OK and go to Tools, Board Manager, Tools, Board Manager. You can follow me here. Tools, Board Manager. Click. Are you following? Board Manager. Now it can, depending upon the updates, it might take some time for the updates. If you have no updates, you can type in the search bar ESP8266. So by default, the support is not given because ESP is allotted with some other that is ESP IDF to program it with the Lua protocol. But the Arduino IDE support it came just because to support the community and to support the products to come out. I mean, faster prototyping and faster manufacturing. ESP8266 and click install. Click on it. Mine is installed, so I am not installing. Click install. That is get installed. So those who are done with installing, so what we can do, we can parallelly start writing the software so that will save time. You can go and open one more session for the Arduino IDE so that we can start running. That won't work now because you are installing. You can open one more session from the search bar. Those who are done, you can write there itself. Maximum. Maximum. Done. All have opened one more ID.
Tomorrow to share करिए better. लेकिन मीटिंग करते हैं इसी शेयर करिए इसी एटा से काम कर ले इसी प्रोजेक्ट रहेगा मीटिंग कैंसिल कर देले शेयर कर देले भलो installed all the number pushing is it
Please go to sketch. Please go to sketch, include library, manage library.
presentation
Manage library, you can type in PubSub client, PUB SUB client, PUB SUB client, PubSub client. Client. PubSub client. Please install the PubSub client. That will give you the support for the MQTT for the ESP8266 port. You can install the later. Okay, can you see Nicolari, the contributor Nicolari, PubSub client? Only PubSub client, nothing else.
please go down yes this down this
Nicolari, he's from IBM.
Nicolari is from IBM and he was helped Nicolari for the processor process.
Please install the Nicolari version. His role is, I mean, very big, tremendous role for making, MQTT open source. There is one more software which you are going to use for web server and all the broker management thing. That is also they have made open source. So those all, those two of the softwares are from IBM. So are you done with PubSub client? Are you done with PubSub client installed? Okay. Now we can write. So before setup, we have to write the headers. Please follow me. Can you see this, or like what I can do? I'll go with black. Now you can see me, no? You can write on Arduino ID, but for visibility, I'm writing here. Can you see this, no? If you are installed, successfully, then those files will come, red, all the headers. So now we are done with the headers and objects. These two we are going to use for the first session. Now, if you see in the ESP8266 board, there's a pin called D1. ESP8266 you are being given. Sir, ESP8266. Are you given or not? No. You're not given. No. That is not breadboard friendly, so we haven't given breadboard. That is a bigger size. So we have given female connectors, no, male to female. That will work. So are you all done with this? Please write SSID password. When the ESP will need internet to connect to the network. So network ID and password. And the gateway for your ESP is this one, this router. The black router there, here, is your gateway for the ESP, not that. You have been connected and coming to this file with this. So now for this, I am not writing the broker IP because you all will have different IPs for your broker. You'll have individual brokers. I'm not writing. That will search. We'll need some serial stuff like serial debugging. So the relay boards you have been given, those are actually operated active low. So we have to initiate the light pin, which is taken 5, and 5 is the synonym for D1. So D0, D1, D2, 16, 5, 4, 0, 2, like this. And D4, D5, D6, D7. So these are like 4, 14, 12, 13, 15, like this. So 5 means D1. You can write D1 also in capital. So we have to initialize the light pin, which is this D1 or 5 pin. 5 is not written, D1 is written. And we have defined is at output and high by default. And whenever needed, we'll make it low so that the relay will operate, the switch will operate. Now in the Wi-Fi begin. What we are doing? We are trying to connect to this IoT Lab SSID and IoT Lab 123 password to the network, and we'll try to see whether we are connected to it or not. Sorry. This is basically, if you're not connected, then you can type in something like we're not connected. You can simply, print here a dot, just trying to connect. Once we are done, we can come here. And can, will take nothing, so that the dot will come and will take a new line. And for debugging purpose, we can take connected to the SSID.
Power supply timing. लेकिन बच्चों को देखो देखिए वो ये लोग ना कर दिला पड़े सर के एडिशनल ले लीजिए এটা অফ ডাউন করো এটা অফ করে দাও Now it is better. Now it is better.
We can write. So in case of actually the job of the PubSub library, they work on the method of this callback function. So the normal function, they just just keep on going, and when this someone publishes, so this callback function will be executed. Otherwise, this won't stop your normal execution. So what we'll do, we'll take a custom function. This will be a type void. Sorry, this won't be void actually. So the parameter. So what are the parameters you will be needing? parameters here in the MQTT network unit topic, unit the data and the data length. When this gets executed, we'll take a debug new message on the topic. Just because of, so this is a complete line. You written this? So this will get executed when new message comes. So we'll type something, new message on the topic and the topic name which is coming. Like whatever topics and data and the data length that will be taken care by the library. Now, for the data length, you put it in a character array. Like we might be sending on, off, 1, 0, anything. So they all have to be character. So we have put it in a message. Now we are comparing message. If this is on, turned off. Okay, on means this to be low. So I'll just reverse it. Off. So if this is off, turned off, and at the same time light pins should be high because that is active low. And the reverse, anything, then in the else there is nothing. Now this is the callback function. This callback function is to be inserted in the setup. So, I mean, it did not be inside this loop. In the loop, there is client loop to handle all this callback function. This one. Library will take care, madam. Library will take care. So actually, what is happening when new data arrives? So this will get executed, but this is not like only topic, byte, and length is coming. You can just ignore topic. You can only go with data and length. So that is the feasibility. They have the feasibility so that you can display topic also. But you don't want, if you don't want to go with topic, I'm just typing because so that I can segregate. Like the data is, it has come from a specific topic that we are printing for debugging purpose. If there is only single topic, you can, you cannot even ignore this topic thing. You can go with data and length also. Sorry. That will decide for different devices, because we are going to subscribe, and we'll publish also. Now, like this is for so this is a load, so this will be subscribed to a topic. So we'll subscribe also. This is written. So this is the callback function. There we have to include this callback. This is to be included in here, and the set callback. Which one?
Callback function, sir. We are not written. We like it. Just scroll it up. Just scroll it up.
Okay. So default port, madam. The port assigning authority, there is this, consortium or this, associations they give. Like there is no reason why HTTP is given with 80 and 443. It's just given. Now this is also, madam, it's given for TCP/IP based communication as 1883. Yes, yes, it's by default. And for WebSockets, you can go with 8883. So this is being set. You can type in and find this port allocation table. I haven't written this broker. That is yet to be written because I'll tell you all this broker's IP. So you all have powered up this pipe. It's powered up all your files. Raspberry Pi. What's the device number that is written on this cover? No, inside. 5. So that is EST Lab 5. The username, I'll tell you the IP. Yeah, this is 5. No, broker IP, I'll tell you. Can you just reset your files? Just restart your file. The third pi, number 3. Your IP is 192.168.0.7. You can type in the broker 192.168.0.7 for third. Device run. I'm writing down the probable IPs because all are showing as Raspberry Pi. I'll be writing down, but how will you ensure that is your Pi's IP? We have given you this port number. This is 5, this is 3. So you have to type. You can open Putty software. And I'll tell you the IPs 192.168.0.5. There is one more 7, 10, 12. This is only 4 pies. Now 7 is gone for 3. This is for third pi. That is reserved. 5, 10, and 12. You can try. And what is the default username and password we have set? This is EST lab, and like if it is 5, then 5. Then EST lab 1, 2, 3, 4. At the you can try. You just have to try 3 options. One is yours. You can drop the option. You can try others. That might not be yours. Your system, but I'm talking about You can go with 192.168.0.7 broker this IP. We'll go for a small tea break and then we'll. से wired रू wireless को penetration टा होनी ये गोटे देखे दवा we'll do with this okay please join us in the tea break.
Okay, we are taking a small tea break. We'll resume in 10-15 minutes.